last lesson, we learned about terms of an expression and their coefficients. For instance, as a reminder, this would be a two-term expression. Coefficient of the first term is 10, coefficient of the second term is 4. In this lesson, we're going to learn to add or combine like terms if they are like terms. For instance, the 10a and the 4a are like terms because they both have a single a. So to be a like term, they have to have the same variable or variables with the same exponents. And we'll get to exponents in a minute. But we got 10a plus 4 more a's. We just need to combine that and say that is a 14a or 14 a's. Just don't accidentally make it an a squared because we're not multiplying, we're adding. Okay, here's another expression where it just happens to start with 4 terms. Again, they all have a single a, so we can actually combine them. We can do 9 minus 7 is 2, 2 plus 6 is 8, 8 minus 3 is 5. So this would reduce to 5a. So again, it's just adding those coefficients, watching your signs, adding or subtracting the coefficients. Now, eventually we're going to get to some that they're not all like terms. For instance, I have a 4-term expression here where the first term is a 14x, but the second term doesn't have an x. We cannot combine those two. But the third term does have an x. So the first and third term are called like terms and can be combined. And the -7 and the 5, because this 5 doesn't have an x, those two are like terms that can be combined. So what we would do is we would combine the 14x to the 13x, getting 27x, and then -7 plus 5 would be -2. And that would be our reduced form where we've added like terms. Now, as you do this, what we want to do is we want to always write things in what's called descending order of exponent, because this next one here has an exponent on this x. So this is an x squared, where this second term has a single x. Those are not like terms. They cannot be combined. This 7 doesn't have an x at all, so it's not a like term with either of those. So you will sometimes see expressions that are already simplified. This is a 3-term expression, and it's already as simplified as it can get. Nothing combines. There are no like terms because this x has a higher exponent than this one. But now what I was talking about descending order is we write the term that has the highest exponent first, then we write the term that has the next level of exponent. So we go from a 2 exponent to a 1 exponent to no exponent. Here's an expression that has multiple variables and exponents. So you don't necessarily have to always write it in descending order, but what we're going to do is look through here and we're going to try to match up like terms. But it's important that a like term has the same variables with the same exponents. So this first term that has an x squared and a y, I'm going to look down and see if I can find any other terms that have an x squared and a y. Well, there's an x squared, but it's missing the y. That doesn't have an x squared. Well, again, there's an x squared, but no y. There's a y. There's an x squared, but no y. So this term here has no like term with it. So the final answer or solution is going to have a 16x squared y as one of its terms. Now I'm going to move to the next term. So maybe I'm going to box that and say that was all by itself. Now I'm going to underline this 9x squared, and I'm going to look down and look for all the x squareds. Well, that's not an x. Oh, there's an x squared, so maybe I'll underline that one, saying that is a like term with this one. That doesn't have an x squared. Oh, but that does. There's another x squared. And that doesn't. So we have 3 terms that have an x squared and only an x squared. So I'm going to add or combine their coefficients. 9 plus 6 is 15, minus 2 would be 13x squared. So then I would go plus, because it's a positive, 13x squared. So now I've added those 3 like terms. Now I'm going to go to the next term, which is a y. I'm going to maybe circle this. I'm looking for all terms that have just a single y. So I come down here. Oh, that term has a single y. That term doesn't have any y's, and there's no other terms left, so I'm going to combine these two here. So a negative 7 plus 8 is going to be a plus 1y. Now remember, if there's no number written in front of it, that's just considered a 1. So we got a 1y. And then the only term left is this 9 that doesn't have any variables, so I write that at the end, plus 9. And that is the simplified form of this more complex expression. This used to be a 1, 2, 3, 4, 5, 6, 7 term expression. I reduced it down to a 4-term expression because I was able to combine the 3x squared terms and the 2y terms. So remember, when you're adding like terms, look for terms that have the same variable or variables with the same exponents. If you have questions, please do bring them to class.